A warm welcome to this platform. So we continue with organic chemistry. This is our lesson number 6. And in this one, we focus on macromolecules. So we are going to focus on macromolecules, everything around this part. So the first part, let us know what macromolecules are. So for macromolecules are just giant molecules formed by joining smaller units. So we can say are giant molecules formed by joining smaller molecules. And these smaller molecules are called monomers. Okay? These are called what? Monomers. So macromolecules are simply giant molecules formed by joining smaller unit, otherwise known as monomers. Now, macromolecules are produced by the process called polymerization. So they are produced by the process called polymerization. And polymerization is simply the joining up of the smaller units called monomers to form large molecules called polymers. So macromolecules are formed by polymerization, and polymerization is just the joining of smaller molecules called monomers to form polymers. So polymer is a giant molecule. Okay, poly, a lot of monomers. So polymers. Now let us have a look at the types of macromolecules. So we look at two types of macro. What are the two types of macromolecules? So two types of macromolecules, they can be put as one. We have the synthetic. So macromolecules, they say they are called polymers. So in other words, here we can say two types of what? Two types of polymers. Okay, two types of polymers. So two types of polymers, we have synthetic polymers. Now, synthetic, without wasting time here, synthetic just means man-made polymers. So these are man-made polymers. Then the other one we can look at is natural polymers. So natural polymers existing naturally. Okay, so we are going to look at each of these. So we are going to start with synthetic polymers. So like I've already said, synthetic polymers, these are just polymers that are man-made. Okay, these are just polymers that are what? Man-made. So for synthetic polymers also can be into two. So two types of synthetic polymers. What are the two types of synthetic polymers? So one, we have what we call for synthetic polymers, we are saying there are two, and we have what we call additional polymers. These are just simply made by adding unsaturated compounds, or I can be specific and say by adding unsaturated molecules. In this case, this is formed when alkenes react. So alkenes undergo additional polymerization. So when you deal with additional polymerization or additional polymers, just know that we are going to look at the polymers that are formed by alkenes. Then the other one we'll discuss it later, which is condensation polymers. So I can just maybe include it here. Condensation polymers. Now, condensation polymers, as the name suggests, so these are polymers that are formed, but in the process there's elimination of water. So we'll get to dig deeper when you get there. But at the moment we can start with additional polymers. So as the name suggests, additional, so which means we are just adding, okay? You are just adding the smaller units. So additional polymers here are just polymers that are formed by joining a smaller identical or unsaturated monomers. So are simply polymers formed from smaller, okay? So polymers formed from smaller identical unsaturated monomers, okay? In this case, alkenes. Okay. Now, let us look at the examples. Let us look at the examples. So, for example, so pay attention on this part because the question do come either you have to write the structure of the polymer formed or you are given the polymer, then they ask you of the monomers that or the initial monomers. So an example of the polymer that we'll look at is polyethene. Now, as the name suggests, polyethene. So poly, which means a lot of ethene molecules added to form polyethene. Now look at this. This is ethene. Then another ethene. I can add another ethene. So 3 of the ethene here adding. And let me just emphasize, one thing that you should know about this is that only a polymer is produced. So now, you know that the double bond in the alkene breaks, and when the double bond breaks, there's room for attachment of other atoms. So this one is going to attach to this. So the double bond, when double bond breaks, is going to attach to this, also that one to that. So you're going to have a polymer with 3 subunits. So 3 subunits, they have 6 carbons. So I can draw the carbons joined with the single bonds. These are 5 of them. So 1, 2, 3, 4, 5, 6. Then I can leave a space at the end. All these parts occupied by hydrogen, 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 even down there, hydrogen, hydrogen, hydrogen. Okay, so this is what we call polyethene. And in this case, I'm showing how many? 3 subunits. So sometimes you'll be told specific number of subunit to show. In general, so if you have an alkene, that is ethene, in this case, this number represents number of subunits, resulting into a polymer, which is polyethene, with a lot of subunits. So to show that it's a continuous chain of this, you just put it like that. Then of course you're going to write N. So N represents the number of subunits there that are joining. Okay. So otherwise, this is the polyethene. What is the use of polyethene? The uses of polyethene. So this is very important to note that even as the number of carbon increases, also the texture of these changes. So for example, the polyethene is a soft is soft. It makes soft plastics, and therefore they are used in making of plastics and or even making of squeezing bottles. Anyway, away from this, the other thing that would look at, maybe the other example, let me say example number 2, still looking at the additional polymers. In this case, let me give a different one, and let us look at polypropene. Now, I want you to understand something. Sometimes the structures might be given so confusing to know what is the monomer. So now, propene, we know that is drawn like this. Okay, that is propene. I guess you'll still remember. So propene is an alkene with 3 carbon, but at least you know that between 2 carbon, there's a double bond. So this is propene. Now, when it comes to presenting this one, where additional polymerization is concerned, you want to expose the double bond, and therefore the whole of this subunit, you write it more like it's a hydrogen right down here. So you write it down here. And how do you change this one? So this whole one is going to be, how many carbons does it have? 1. How many hydrogens? 3. So it changes to this. So in other words, propene, you are going to draw it like this. We are saying want to expose the double bond. So you draw it like this instead of putting it like that. So which means another propene I can add here. That is another propene. This is another propene. Okay, let me just put 2. So now when the double bond here break, here, there's going to be room for attachment of other atoms. So this is how it is going to be. So which means the polymer in the straight chain will have 4 carbons like this. Then don't forget this, you leave it open. We have hydrogen, 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 hydrogen. Then there you leave it open. Now, not hydrogen here, please. Look at this. And also here is not hydrogen, but something like this. Have you seen the way it appears? So this is polypropene. This is polypropene. How many subunits here? 2 units. Okay. Now, sometimes you might be given something like this. Let me put the same one. You might be given this instead of writing the polymer. So you are given the polymer, the same one. Okay. I want you to understand something, especially on how you determine the subunit. Okay, if you are given the polymer, how do you determine the monomer? So here it is. Now, if I ask you, what is the initial polymer? I mean, what the initial monomer? You have to cut this into 2 and just consider this one and count the number of carbons. So number of carbons, we have 1, 2, including this one, you count it. So 3. You know that alkenes are the ones that form these polymers. So already you know that it was an alkene that reacted. But what is the name of the alkene with 3 carbon? And that is propene. Okay? Now, what about if you are given something like this as a polymer? Let me say something like this. No. Something like this. Then here we have C3. And there you have C3. Hydrogen. Hydrogen. Then, okay, let me put it like this. There you have also C3. Hydrogen. Hydrogen. CH3. CH3. Hydrogen. How many are these? 1, 2, 3, 4, 5, 6. Okay, so you have hydrogen, CH3. Then the question is, from which monomer, or what is the monomer of, what was the initial, the initial monomer for this one? Or what is the monomer from which this polymer was formed? So now what do you do? Like I said, the strategy is to cut these into two carbons, because you said when forming these, always you expose the double bond. So no matter how long the chain is, you're going to orient it where you expose the double bond. So only two carbons here. Then now, whatever remains can be up or down. So that is your target. So when you cut one of the piece here, which is CH3, carbon, then carbon, again CH3, you are going to count the number of carbons. How many are they? So number of carbons, we have 1, 2, 3, 4. So this was butene. Okay? This was what? Butene. So the subunit was butene. Now, if you are to look at it, it was a butene like this, which means this side, there's a hydrogen here, a carbon that is like this, because the double bond is in the middle. This is what it means. Then butene, is it 4 carbon? 1, 2, 3, 4. Yeah. Like this. Then here also like that. So it was this double bond here. That is 2. It was this double bond here. So which means this one was just written down like that. And also this one was written down like that. So forming this that you are seeing. But otherwise, that is how you identify it, or how that is how you identify the monomer. So very important that, because these questions are some of the questions that you find. So that is how you can look at it. I guess you've gotten a thing here. Okay. Do we need to look at more here? What about we look at another example here of an additional polymer. This time around, we look at PVC. So PVC, so example number 3 for the polymer, additional polymer. So we look at PVC, polyvinyl chloride, otherwise PVC. Okay, which is also known as the polychloroethene. Polychloroethene. This is polychloroethene, please. How about this one? So for this one, the structure is this one. Okay, so it just have a chlorine in it, like this. Then plus another chloroethene. So when this join, it is going to form a thing like this, which is polychloroethene. Okay, so this is an important polymer, which is called polychloroethene. An important polymer that is used in making of plastics, paint. What else is PVC used for? Making waterproof clothing, electric cabling, and all that. So these are some of the use of that is polychloroethene, which is PVC. All right, you should be able to look at also classification of plastics. So make sure that you look at this part. Otherwise, you can look at the other type of synthetic polymers, which are condensation polymers. Now, condensation polymers, we know that these are formed by elimination of water. So a condensation polymerization involves two subunits. Okay, so we can say involve two subunits which combine to form a polymer, and in the process water is eliminated. So there's an elimination of water here. So condensation polymer just involve two subunits which combine to form large molecules with elimination of what? Water. What is more important here is to look at the type, the condensation polymers here. One of them that you are going to look at is the nylon and also terylene. These are examples of terylene, please. Terylene is this, the spelling. Okay, so these are the ones that we are going to look at. So we'll start by looking at nylon. What about nylon? So nylon, what is important here is the monomers that are formed. So nylon is a tough material. And in this case, like I said, what are the monomers? So nylon, we can say, is a polymer of two different monomers. So nylon is a polymer of two different monomers. Like I said, pay attention to the monomers. Diamine, that is diamine. Otherwise, in terms of structure, we just put it like this. So diamine, which means it has an amine group. Let me just put, it has an amine group. Amine group is this one. Now, in terms of structure, we can draw it like this because sometimes you'll be asked to draw the monomers of this. So diamine is like this. This is diamine, which means two amine functional group at the end. So this is diamine. So monomers of diamine and dicarboxylic. These are the monomers of nylon. So dicarboxylic, otherwise the functional group of dicarboxylic is, the carboxyl group at the end is this one that we already know. This is the functional group at the end. Now, how does it look in terms of a structure? So let me just put a different part here. So it looks like this. This is the dicarboxylic. So it is this and this that react to form nylon. So let us look at how we can put them. So we have this. I'll start with amine. then of course reacting with dicarboxylic okay, so here I can put another functional group here like that. Then here I can add another amine like this. So a lot of them join, and what is formed is what we call nylon. Okay, so at the end I can just leave it open like that. Now, how does a reaction occur? So here, the reaction, how it occurs, this hydrogen together with OH there is eliminated as water. Also here, that water is produced. That is condensation reaction. Now, how does the structure appears when they join? So it is this part that joins to the carbon there. Also, this part joins to there. Let me just try to draw how the structure appears. So we are using this. Okay, I'll use different colors so it is going to appear like this. I can put the hydrogen down like that, then connected to what? Connected to this, then another one we can connect it there, which is like this. Like this. So I can put these to differentiate them like this. So it can be a continuous chain. So now what we are interested in, so this is how the polymer appears, can be a continuous chain of these. And I'm sure you've seen these in the past papers. Now, again, the other thing that we are interested in is to know what is this linkage. So this is called a linkage. What is the name of the linkage? So questions that you expect, what is the name of the linkage? And also draw the structure of a linkage. So to draw the structure of a linkage, the linkage is simply looking like this. So if you're asked to draw the structure of a linkage, this is what you just put up. And this is called the amide linkage. Otherwise also known as what? The peptide linkage. And now, very important to understand is that on the natural polymers, we are going to find another one that has this kind of a linkage. So take note of it, amide linkage. As we go on, make sure that you come back to this one. So that is about nylon. Now, what are the uses of nylon? Uses of nylon. What are the uses? What are the uses of nylon? So, nylon is used in making of clothes. So, making of clothes. Making of ropes. Making of ropes. So, what are some of the uses? So, make sure that you do comment in the section, in the comment section, some more uses of nylon. Otherwise, you can proceed to look at the second one, which is the terylene. What about terylene? What do you need to know about terylene? So, for terylene is a polymer which is formed by condensation. That one we know. Now, also under this one, what is important is to know the subunits. You know already that it is formed by condensation, polymerization. Now, terylene is made of two different monomers. That is what we are interested in. Two different monomers of hydroxyl, which means OH, of hydroxyl and carboxyl. Now we know that carboxyl is this. So terylene is made of two different monomers of hydroxyl and carboxyl. Okay, so let us look at these. So hydroxyl, this hydroxyl looks like this. Let me try to do this. Looks like this. Then here you have this. So this is the hydroxyl. Then the carboxyl, like this. Like this. Okay, so when these two react, that is what result into, not two or a lot of these react, that is what result into what we call terylene. So let us look at how they join. So you have the first one here reacting with then of course like this. Another one here. Okay. So if you have such, we said this is condensation. So the joining result into the formation of the bond or elimination of water, result into the formation of the bond and water is eliminated. So this carboxyl group is the one that contribute the OH. Then of course the other one, which is the hydroxyl, is just the H. So even right here, this. So in the process, we are saying water is eliminated, but how is the structure going to be? So in this case, let me shade this. Let me shade this. So we are going to have something like this. So when this is eliminated, this carbon will join, it will join direct there. So how is it going to be? So it is going to be like this. And I hope everyone here is following. So this is how the polymer is going to be. So repeating units. I'm sure these are some of the things that you would have seen in the exams. So now, again, the interest, what is the bond? Or how can you draw the bond? So the bond is this one, or the linkage. This is the linkage. Okay. So what is the name of this linkage? So this linkage is called ester linkage. The linkage is called what? Ester linkage, and that is how you draw it. So this, the whole of this, if you see something like this with ester linkage, so the linkage, I think, should be able to help you to identify the polymer. So that is called ester linkage. What is the use of terylene? Also used in making of clothes. It's also used in making of clothes. Aside from that, can be turned into, okay, so this is just the same as clothes, can be turned into the fabric that can be used to make clothes. So find out some more uses of this and also be able to contribute. Now, we continue, and the other thing that we can look at here is pollution caused by polymers. What are the pollution caused by polymers? So one of the pollution caused by these is air pollution. How does they cause air pollution? We said these are plastics, okay, or they are used in making of plastics. So let us imagine the plastics. How are they recycled? Some resort to burning them, and when they are burned, they produce the smoke that contain some harmful gases. As a result, they cause air pollution. When the plastics are dumped on the environment or just on land, causes land pollution. But one of the major pollution here, we can talk of air pollutions as we try to recycle them. So that is another thing that you need to look at. Now, what are the advantages? What are the good part of having synthesized or synthetic polymers? What are the advantages of synthetic polymers? One, they are durable. Okay, they are durable, easy to use, light. They are thermal and electric insulators. They are flexible to use, as I've already said. So these are some of the advantages. But again, you can look at the disadvantages, the bad part of these, or the disadvantages of the synthetic polymers. One, they are non-biodegradable. Non-biodegradable. Now, I've seen a question here, what it means by non-biodegradable. What does it mean, non-biodegradable? It means they cannot be decomposed by bacteria. So they are non-biodegradable because they cannot be decomposed by bacteria. Okay, that is one disadvantage. Then when they are burned, produces pollutants, so they pollute air when burned. So another disadvantages. And why people resort to burning these, we said because they are difficult to recycle. Now, bringing us to the other thing now, what are the reasons? What are the reasons for recycling these molecules? What are the reasons for recycling plastics? What are the reasons for recycling, which means reusing them? Why not burning them? Why not burying them? So, one of the reasons for recycling is that they are difficult to dispose of. They are difficult to dispose of. They are difficult to dispose of. So, you resort to reusing them. Okay. I think that is the main. Okay. What could be other reasons for recycling these plastics? The other reason why the other reason for recycling is because I think I said this already. We are saying they are difficult to dispose of, and also we don't want to ban them because they cause air pollution. We don't want to throw them out. They cause land pollution or water pollution here. So those, if you think in those lines, then it's just okay. Okay, I think that is where we can end in terms of synthetic polymers. What we can look at now are natural polymers. What are natural polymers? So these are naturally existing polymers. And one that we have, or natural polymers that we have, one, proteins, carbohydrates. So natural polymers that we have, proteins, carbohydrates. Then we have lipids. These are natural polymers that we have. Now, looking at proteins, we are not going to go into biology where we discuss the uses of proteins, this and that. I think our main concern here, so we are going to start with proteins, please. Like I said, we are not going to go into detail describing what protein is, or the uses of protein. But instead, we just go direct to look at the basic units of proteins because that is what we're interested in. So proteins are made up of amino acids. So that is what we're interested in. So amino acids. Now, an amino acid has a carboxyl group and also an amine group. Okay? At one end, it has the carboxyl group. The other end, it has the amine group. So let me just maybe an example of an amino acid looks like this. Okay? So where you find it has a carboxyl group at the end and also an amine group at the end. So something like this. So this is an amino acid. As you can see, at the end there's a carboxyl group. The other end is an amine group. So now, protein is made up of amino acid, and about 20 amino acids, they combine to form proteins. So in this case, what we are interested in is just to show the reaction of these amino acid and the bond that is formed. So let us have this example. Okay, it's an amino acid. So joining with another amino acid. So a lot of amino acid, when they join, they form a protein. So now, you orient them in such a way that the carboxyl group of one amino acid faces the amine group of the other amino acid. This is what I mean. So we can have this. Okay. So as you can see, this is the amine group of this amino acid. This is the carboxyl group. And of course, okay, they are facing each other. So what happened? For these, they react. Remember, this is also condensation reaction because water here is eliminated. So this and that is eliminated as water. So which means what you are going to form is the bond between, and be able to remember the bonds that we've looked at. So what is going to form is this. Let me just put this. So here that part goes. So you are remaining with this, then attached to this. So you're going to have this. Then of course I can put the hydrogen like that. Can put this, that. Then we have something like this. So now, what bond is here? So the bond that you are able to, or that you should be able to see, is this one. And what is the name of this bond? Remember where we are coming from. This is an amide. Not the bond, please, but the linkage. This is an amide what? Linkage. Or peptide linkage. You remember which synthetic polymer or artificial polymer had this? Which synthetic polymer had the same bond as this? Those are the questions that you expect. Okay, so if you look at it, if we are to go back and just check, I underlined it at some point. Not this one. Where is it? Amide linkage. So this one was on iron. If you look at this, does it look the same as the one that we are dealing with? This one, of course. So nylon as a synthetic has the same linkage with proteins. So take note of that. All right. Let us look at lipids. What about lipids? What are the subunits? So lipid is made up of fat acids and glycerol. So these are the subunits, fat acid and what? Glycerol. Now, in terms of a structure, it appears like this, fat acid and glycerol, and also pay attention to the what? The bond. So, like this. This is the whole glycerol. Then you have 3 fat acids joined to this, otherwise joined like this, with a long chain. Something like this. So now pay attention to the, so that is a fat acid, or that is a lipid. So a lipid is made up of glycerol and fat acids. So these are fat acids. Fat acids. Also, this is a fat acid. That is a fat acid attached to the what? The glycerol. Now, what is the bond? The bond that is there is this one. And which one on the synthetic has the same bond as this one? So if we are to look at this, the one that has that bond is this one, which is the pterylene. So on the synthetic, so synthetic is pterylene, has the same bond as lipids. So these questions are the ones that you expect. So take note of that. We can end by looking at carbohydrates. What about carbohydrates? So carbohydrates, what are the polymers for this? What are the monomers for this? What are the monomers for carbohydrates? So carbohydrate is made up of glucose. Okay? Let me say repeating units of glucose. Repeating units of glucose. So now you have a glucose like this. So this is a glucose molecule or monomer. So repeating units, which means glucose, glucose, glucose joining. So it forms like this. Also is a condensation polymer because water is removed. Oh, why am I joining them already? So when you find this structure that I'm going to draw in an exam, just know that that is glucose. I think glucose is different from O. You will be able to, or mean carbohydrates, you'll be able to identify them easily. So now what happens? So here they join. Water is removed. Water is removed. And what you are going to find in the exam is something that looks like this. I'm sure you've seen this in the exam. Continuous chain like this, but at least you have an idea of what I mean. So this is called carbohydrate. So when you see such, they ask you what is the polymer. The polymer is what? The carbohydrate. Now, what is the monomer from which, or draw the monomer from which it is coming from? So to draw the monomer, you just put up this. This is the monomer. I guess you've gotten that. So a monomer, where it is coming from, the structure is this. Then the polymer that comes out looks like that. And the polymer is called carbohydrates. And by what process is it formed? Condensation reaction. Now, what is the name of this bond between? This is called glycosidic bond. Okay, it's called glycosidic what? Glycosidic bond. And this, or glycosidic bond. If we were to draw the linkage there, I think we just put something like this. I hope we are together up to this point. All right. I think this is what is important for you to look at as you prepare for your exams. Now, it has been a long journey from the start. From the start of the topic, just a recap of what we looked at. So, we defined what organic chemistry is. We looked at the terms under the study of organic chemistry. I'm sure by now you know them, which is just hydrocarbons, homologous series, functional group, and all that. Then afterward, we looked at the prefix and the suffix, that is nomenclature, how to name the organic compound, which just takes into account the prefix and the suffix. We started looking at, or we looked at alkanes. Under alkanes, we looked at the reactions that alkanes undergo. Then we looked at alkenes. We looked at alcohol, carboxylic acids, esters, and now today we've just concluded with macromolecules. So this is a full coverage. The only part that is remaining is on fractional distillation of crude oil. Make sure that you look at that part, and also focus on cracking. When you are given the product, how do you determine the molecule that was cracked? Or if you are given the molecule, how do you determine the product formed? Now, this is a coverage in terms of a topic, but I have also another video where I did all the questions, and of course the video is just right here. So what I'm going to do, I'll put everything in a playlist so that you can easily find the recordings. Otherwise, we can end here and see you in the next topic. But before we go, if you've not subscribed to this YouTube channel, make sure that you do so. And if you are interested for online lessons, you can just get in touch on the number 0976 402563. If you are interested for physical lessons, you can visit us. We are found in Kabwata, just near Kabwata Primary School. If you stay in that area, you can still get in touch on the same number. If you stay in that area, you can get in touch on the same number. Otherwise,